your line work is at the elevations that it ought to be in terms of the Z coordinate system, the Z aspect, the Z axis of the coordinate system. After you do that, that's when you'll be able to progress into the next steps. The point system, if you're going from AutoCAD directly, it's obviously more accurate. If you have to use the point system from Revit, it can be a lot slower, meaning you're just entering in the points manually. And triangulation, I'm sure all of us have seen how Revit does triangulation. At times it can be at inconvenient places, or if, say, you have a curve that's doubling back in on itself, that curve, it may just go straight across and miss it, so you have to add points in the middle of the curve in order to get it to work out. Again, this is all focused on a manual integration of the points. Right, as far as automatic, we'll get into that in just a second, but the key thing that I found in going through all this is you need to make sure that you note what layers your topography is on, so that you'll be able to only select that layer when you're going into the next phase of using it in Revit. Okay. So next, picture it in your mind, a CAD file, a CAD site file, okay? And you have a point that can either represent a building on it, or maybe a point that is a point that you can use as a reference. What you need to do is find the location of that point in AutoCAD, okay? You do that using the point command. Have you guys done this kind of thing before? No, Emiliano has, but have the rest of you, in terms of within AutoCAD, using the point command? What the point command does, Emiliano, you can chime in if you like at any point, but basically what the point command does is it gives you the specific references of the point in relation to the 0, 0 of the AutoCAD file that you have there. Okay, so if you use the point command and you use that in combination with a command called PD mode, you'll be able to basically have a crosshair that you can then select in the AutoCAD file and move to wherever it is that you want. So let's say you get, you have the original topo and you get the topo back from the civil engineer. You can use the point command in order to locate the point where in the civil drawings you would probably have your building pad located, okay? And so what we're trying to do is bring AutoCAD in at a specific point related to the survey point in Revit. And so this is how you're getting that specific information instead of bringing the AutoCAD file in on center to center or one of the other options. Let's see. I don't have them memorized off the top of my head, but instead of bringing it in center to center, what way do you guys typically bring in the AutoCAD files?
We just import it.
Just import, but on the settings that are on the right-hand side, in terms of how it's brought in, there are a number of options.
I just put VB import, attach DWG.
Okay.
And it brings it in and we just move it around
to wherever it is
that we think it is.
Okay. So this is the way that I'm talking about is a way of automatically bringing it in at a specific point relative to everything. So the basic idea here is from within AutoCAD that you use the point command to establish the point, you use PD mode to show the crosshair, and you have to kind of blow that up a little. And what I came across is about 30 times the size because it comes in at 1 pixel. But you need to be able to see what that, where that crosshair is. You click on it and that gives you your X and Y coordinates. Okay, at that point you can either write those down, use a snipping tool or a screen capture so that you have those points ready. Okay, next. So this is my screen capture for the day. From within Revit, and obviously you've saved all this stuff in your CAD file that you're going to be linking into Revit. You're going to get your survey point by way of VG and unhide it by way of the site, or showing it in VG, with the drop down menu that we've gone through before. And in the Manage tab that you see here on the screen, where it says Specify Coordinates at Point, that is where you would then enter the XY coordinates that you had written down from the CAD file, so that if you're clicking on or have indicated the edge of the building, like the corner, the bottom left corner as an example, as the point to which you want to specify the coordinates from the AutoCAD, you'd also be doing that in Revit, and you'd do it from this location where it says specify coordinates at point. So you would have gotten your X and Y from the AutoCAD file, and you're bringing it in by way of this command, or you're specifying the point when you bring it in that it would go to.
A question.
Okay.
So the X and Y in AutoCAD, and that's relative to its origin or base point, correct? In the AutoCAD file. So is this coordinate system the same? For example, you bring in your pad point, at 100, 100, right? Let's say 100x, 100y. And then you specify coordinates at point and you type in 100x, 100y. Does that bring it in the same location?
Yeah, that will.
It will, okay.
Mm-hmm.
Now, also the z coordinate.
You would specify that as well, or you can specify it from here, or you can specify it from selecting the survey point, the little triangle with a plus sign in it.
Okay. So you either leave the survey point where it is and then bring in the I guess the contours at a higher elevation, or you bring it in at
And then you
0, 0, and then you move down
Right.
the survey point.
Yeah.
Ah, okay. All right. I
So-
see.
Alright. And like I said before, when I've gotten a chance to do this, I'll be taking screenshots and go through it with an actual example. Okay. So when you click on the specify coordinates at point, little drop down menu thing there, it will then give you a dialog box where you can specify the X and the Y. The X and the Y are going to be in feet and inches. Most likely your civil work would be in decimals. Yes, feet, but the inches will be decimals, so Revit will convert it. So not to worry about that. Next is importing or linking your CAD. Use the drop down for auto by shared coordinates. And this is something, again, I'm going to get a screenshot of this. But basically, instead of loading it in at center to center, you're loading it in according to the specific coordinate point that you have told it to come in. So it takes the guesswork out of your process. Okay. And so once it's in, you've created your topo surface. At times there are going to be some stray points that are like maybe 10, 15 feet or so high or off mark, you just need to look at it and make sure that any stray points are either deleted or they're selected and the elevation brought down to others that are in the same topo line. Right. And we're doing this to smooth out the irregularities and triangulation that Revit line. Okay, you click on finishing the surface, and then you have the capability of editing points. Now, in this editing points slide right here, it's just basically if you have that area that I was talking about where the line curves in itself, it becomes concave and Revit triangulates across, selecting points in the middle of that and giving them an elevation of just a little bit higher than the surrounding contour will most of the time straighten them out. Okay, so now we determine cut and fill. You have brought in the CAD file, okay, and you created your topo surface, all right. The phasing of the topo surface is the thing that's going to be able to get you your ratio between cut and fill, all right. What happens is you have in the view where you have brought in or created the topo surface as the existing surface, you're then going to, by way of another command from Revit, the grading icon, and I'll show you guys that when I can jump over to Revit in just a moment. But from the grading icon, when you bring it in, or let's see, after you've generated the first topo surface showing the existing, it will generate a new topo surface. It's basically a copy of the old, but by way of moving the points around of the topography, you're either cutting or filling. And so when you cut or when you fill by way of moving the topo points around, that's going to give you your final amount of cut and fill. Okay, so steps here: ensure you have the existing topography entered, selected, designate it as phase created existing and phase demolished during construction. Okay, next click on the graded region icon and select create new topo surface exactly like the existing ones. That's a little menu item that will pop up when you say click on the graded region and create new topo. So we'll create a new topo and then you'll be able to get the precise amount of cut and fill from that. Okay, I know we're kind of working in the dark here without the screen capture shots, but hopefully when I go to Revit in just a moment, you'll be able to see it better. So, alrighty, so I am actually going to change the display settings so it's just mirroring what's going on here on the computer. Just a second. Okay, so the it's not doing what I wanted it to. Anyhow, this is from within the create topo surface command, right? And I'm not doing that. This is just a flat drawing. This is not.
It's not in 3D.
Yeah, and so I would need to actually trace over these if I was going to, or somehow find the original CAD file. Anyhow, let's go to massing and site. Property line is not the one. Graded region is. So this is the one where if you already have the existing topo before the civil engineer has gotten to his work, and you then execute this command, and you have also the civil. So you have the original topo, you have the civil using this command with the graded region by way of you've already developed the mass from the existing topo. Using this command of the graded region enables you to then take the difference between the cut and the fill, and also to move the points around so that you can get the proper ratio of cut to fill and get the precise amounts of the cubic feet that are necessary. And again, I wish I had an AutoCAD file that I could show you the exact process with the screenshots and whatnot. But anyhow, this is the big picture, and we'll get into that eventually. So this is the way it's done, using the graded region, and that will give you your cut and fill. So any specific questions, so that when I present this again and I have AutoCAD on my machine, that I'll be able to help you better. Anything specific coming to mind?
No, I think once I see the process a little bit more, then I'll think it'll make more sense. But right now, I'm a little confused about the graded region versus the existing topography. So
what it does functionally is it copies. It's like if you had two masses on top of each other. Okay, the first mass was the original topography. The second mass is what you're going to be changing it to. Within Revit, you have the capability of phasing the project, such as like with walls. If you did as-built drawings of a house, you would show all those walls as existing, not to be demolished, or you could indicate certain walls as to be demolished and the new construction phase. But just like you can do that with walls, you would also do that, you can also do it with topography, so that in the existing phase, existing to be demolished or to be cut, is the way that it is. The cut would be happening in the phase of new construction.
Okay.
So what it does is it basically takes the difference from one model that's sitting on top of the other model, and you can then show the differences in terms of height and
How does it show that? Does it create a grading plan?
But it shows it by way of, you can show it in topo lines as well as in 3D. What it does is it changes the color of it in 3D. And by way of grading, you can show that as a differing line type.
Right. Dash or solid.
So, yeah.
But the cubic feet, could that be like created as a chart? like the cut and fill?
I don't know if it can be created as a chart. I do know you can have the amounts, like, have you done?
I've seen, well, like you're saying, so like a chart, no, you don't mean like the amounts?
Mhm.
It's different? Yeah, it'll do that for you, I think,
Yeah, like,
not sure exactly where,
you
but.
know, when you get a
I know
civil,
it
it'll
is.
say cut, fill, you know, and then, you know, what you're gonna export, basically what
Yeah,
you're not gonna use.
there's a percentage and stuff.
It's probably similar to the way you do the other quantifiable amounts in the schedules. So that's what I would think, but
So in terms of, the grading plan, when you would get it back from the civil engineer, you would wanna offset it as well, right? That way Revit can see it both, does it wanna see it both in 3D to be able to generate that? Like
But,
show that how
yeah,
it's.
if you get it back from the civil engineer and it isn't in 3D, you would need to make sure from AutoCAD that it is.
Okay.
That your z-axis is reading properly.
Then that the coordinate you used originally would be the same coordinate, correct?
Yes.
Okay. So once we get, okay, so let's say we created our graded region. Does that graded region represent the new topography, or is it just a tool to describe the cut and fill? In other words, as we move around the graded region to match our design, does that now become the new topography that when you cut a section, you'll see that
Yes.
line? Okay.
Yeah. Yeah. So it will show up in section as you cut it, and it's precise based on the civil that you've done.
Well, originally what you're doing, and then you send it over to civil,
Mm-hmm.
they should send you something back.
Mm-hmm.
Um,
So you bring it into your model, and you see the accurate slope.
cool.
So
Mm.
So that's the process, and like I said, I will be getting into more specifics as we go along. And so this was encouraging to me, especially bringing it in, or being able to bring it in at a precise point. Because it can seem like you're just guessing out there, and guessing, especially when what you're doing is affecting, tens of thousands of dollars for your clients' money, is not a good thing. It's good not to guess. It's good to have the exact locations. So, alrighty, well, that's all that I have for right now, and again, if you guys have any other questions as you go along, you can shoot me an email or ask, and I'll try to respond as quickly as possible. And it seems like I'm better at this in the earlier part of the day, after lunch or closer to 5. So,
Cool.
alrighty, guys.
Thank you.
Thank you.
Thank you.